In this video, we're going to dig deeper into more JavaScript integration. It's very exciting. First, we can use the external keyword to bind to any JavaScript library. There are several kinds of externals, differentiated through the attribute they carry. For example, we can bind to a global JavaScript library using @fal. So we use the external keyword to signify that this is an external JavaScript integration, and we have to put the attribute @fal here. This setInterval has two arguments. One is a function that receives nothing and returns unit type, and the second one is an integer, signifying how many milliseconds we want our interval to be. And this one returns float. This is not really a float, but let's fix that later. So after the equal sign, we have string and then setInterval here. The string here signifies the actual function name that is available on JavaScript land. Now let's take a look at the compiled JavaScript code. It's empty because we haven't used it. Rescript knows that you have unused code, so Rescript just doesn't compile it. For one more example, let's create a binding for clearInterval. So clearInterval is a function that accepts float and then return a unit type. Now is the time to fix our float problem. We can improve this code to take advantage of Rescript's powerful type system. So let's create a new type here called interval ID. And then we can put the interval ID as a return value of setInterval. We can also put it in clearInterval as an argument that it accepts. In here, we don't really care about what type of data that setInterval returns, but we know that the value can be used by clearInterval to clear the interval. So we just make an abstract type called interval ID and use it like this. Let's try to use this function. We see that Rescript doesn't complain. That means the type checks. As you can see, we're very comfortable in Rescript land. Let's see the compiled code. Now Rescript finally generates the code because we are using the setInterval and clearInterval. Next, we want to bind to a global JavaScript variable that has a namespace. For example, the math.random function. We use the same syntax that is using external and @val, but there is also another attribute called @scope, and that's where we tell Rescript that this is using math library. So random is a function that accepts nothing and returns a float. This is the way we bind random to math.random. Another example is to bind json.parse, but we can type the return value as the type that we're expecting. So in here, we bind the JSON parse into two functions. One is parse into person and the other one is parse into animal. So we can use these two functions to return the type that we expect, and it will be type checked by the compiler. Okay, so this is actually not a good way to safely parse JSON because there is no guarantee that the string is what we expect. But don't worry about it for now because we'll learn a better approach in a future video. For now, this serves merely as an example. Using the @scope attribute, we can bind to an arbitrarily deep nested object by passing tuple to scope. As you can see here, we know that window.location.href has a property called length in the JavaScript land. So here we are just binding the length function into window.location.href.length. Let's talk about @send attribute. Sometimes there's a case where we want to bind a function that's attached to a JavaScript object. For example, we know that the fetch API returns a response object, and then we can call .json to get the JSON. We can use the @send attribute to do that. Don't worry about the promise syntax because we will learn about this in the next video. So we know that the fetch API returns a response, and we want to use the response and transform it to JSON using the .json. The fetch returns a response, and the response has a method called .json using the @send here. But because Rescript doesn't have object-oriented concept, we have to pass the response as the first argument in the JSON function. And then you can use the JSON like this, or as we have learned in the previous video regarding pipes, we can also use the pipe operator. This makes it look more like the JavaScript counterpart if you like this kind of syntax. Let's take a look at the compiled code. So the compiled code is very straightforward as you see here. There's nothing else added by Rescript. It's very straightforward JavaScript code. Alright, lastly, what if we want to bind to a JavaScript code that comes from a node modules? We can use add module. Here we know that in Node.js land, we have a path module, and the path module has a dirname function that receives a file path, that is a string, and it returns a string of the directory name. Let's take a look at the compiled code. As you can see, the compiled code is very straightforward, like usual. You can pass string path just like JavaScript require or import to the module. Let's say we have a utils JavaScript file that exposes an add function. We're just requiring it here in Rescript. Let's take a look at the compiled code. Now this is very interesting because Rescript adds another layer on top of utils.add. If you know why, please put the explanation down below in the comments so we all can learn together. There are several other ways to bridge from JavaScript to Rescript. I encourage you to take a look at the documentation for more details. Lastly, please just use Rescript core because chances are they already implemented most of these Rescript bindings. Only use this for an external third-party libraries that you bring into your code. That's all for today. Let me know down in the comments if this is too confusing or if you have any other questions. Don't forget to like and subscribe. I'll see you next time.